scientists turn their attention to the volcanic islands of Hawaii. Locked inside this ancient lava is a pristine record of Earth's magnetic field stretching back millions of years. Professor Emilio Herrero Bavera is searching for clues to Earth's magnetic past.
One of the reasons why we're coming here is because we're looking at lava flows that are relatively thin. You can see the boundary of this lava flow, and this is the other boundary. From here you see another one, and another one, and another one. All these fantastic sequence of lava flows. We're talking about 300 flows, 400 flows.
Molten lava from these island volcanoes accumulates over millions of years. When the lava flows hit the seawater, they cool rapidly, creating snapshots of Earth's magnetic field strength. By analyzing different samples of lava, Herrero Bavera has built up a picture of how the field has changed since long before humans were around.
They are actually the recorders of the Earth's magnetic field in hundreds of years, thousands of years, and this is what we need actually to know something about the Earth's magnetic field.
Lower layers of rock take Herrero Bavera progressively further back in time. To unlock the information, he takes a sample of the ancient lava, as well as showing how the field strength has changed. The sample will also reveal another vital piece of information. He carefully notes the sample's exact location.
And we're going to measure the magnetization of the sample we collected in the field.
Back at the lab, he analyzes it using a magnetometer. Like pottery, lava contains magnetite. When it cools, particles of magnetite line up with the Earth's magnetic field, like tiny compass needles, recording both its strength and its direction. In this sample, the magnetite aligns with today's magnetic north.
This sample was in place in the past 700,000 years when the field was actually characterized by a normal polarity.
But in older samples, they discover something incredible. The magnetic particles point south rather than north. They date back to a time when the magnetic field polarity was the opposite of today's.
There was a reversal actually recorded by these lava flows. I will be actually able to see a sequence of points that are actually defining the behavior or the evolution of the magnetic field from one polarity to the other polarity.
By analyzing thousands of lava samples, geophysicists discover that the Earth's magnetic field has reversed over 18,000 times in the last 20 million years. On either side of these reversals is a long period of dramatically reduced field strength.
During this process of reversal, the magnetic field drops very significantly in intensity. And this happened many, many, many times throughout Earth's history. You know, the Earth is 4.5 billion years old, and I'm saying it happens every few 100,000 years or so.
Years of research reveals that the last flip occurred 780,000 years ago.
It's easy to understand why there's such an interest in the possibility of a magnetic reversal. The last magnetic reversal occurred more than 750,000 years ago. And so, in a real sense, we're overdue for another. And so the question is not if another reversal will occur, but when.
Many scientists now believe that the South Atlantic anomaly is the start of a global magnetic field reversal. The decay of our magnetic field will accelerate, with serious consequences for life.
The kind of radiation we're talking about is known to damage DNA and RNA and cell structure, and it is a serious cause of cancer incidence.
On Earth, magnetic field reversals are comparatively rare and erratic. But on our nearest star, they occur far more frequently.
Every 11 years, the direction of the sun's magnetic field flips. So the sun's magnetic field oscillates regularly, whereas the Earth has these long periods where the geomagnetic field's direction remains more or less constant, and then it flips suddenly.
Although the sun's magnetic field isn't generated in exactly the same way as Earth's, scientists still observe it closely.
So you get these very different dynamos operating under the same laws of physics, under little different environments. So by studying both of them and comparing them, we learn more about both possibilities.
During its magnetic cycle, the sun undergoes periodic changes in activity. Every 11 years, it enters solar maximum.
This 11-year cycle of solar activity has peaks where there's lots of solar storms, and right now where the sun's taking a little nappy. But in about 4 years, we're headed back for solar max. Big storms, big disruptions.
In 2012, the sun's activity will peak. For 3 years, the buildup of magnetic energy will generate dark sunspots, an increase in solar flares, and hurricane-force solar winds.
Almost every solar max, there are satellites that are killed. The last solar max destabilized the North American power grid and caused massive blackouts during one of the storms. And these are not small storms and inconsequential.
Earth's magnetic field continues to weaken. Soon, this intense solar bombardment could kill more than just power.